have been playing a leading role in this initiative since it was initiated in 2019. So from the beginning, from the development of the concept note, and also for the conduct of capacity building activities throughout this year, Bps Statistik Indonesia and Department of Statistics Malaysia will lead us in the implementation. And for the other ASEAN member states, we really expect that you can participate actively, you can contribute actively, so that our activities can get the results as expected. Actually, this is just a starting point. As agreed by SSS committee in their session in 2019 in Bangkok, we will try to have some efforts in utilizing big data for enhancing our official statistics, both in terms of data availability and if possible in terms of improving data quality. So this is just a starting point, because the difference, the variety of capacity among us, among 10 member states. So we agreed to start the initiative with capacity building program. So we will try to enhance our capacity. We will try to improve our resources so that all of ASEAN 10 member states, the 10 member states, will be able to utilize big data for official statistics. And for these activities, BPS Statistik Indonesia and Department of Statistics Malaysia will be the main resource persons, not only in this part 1 workshop, but also in the next part 2 and part 3. And why I said this is just a starting point, after the series of the workshop, we will develop a plan for conducting pilot project next year. So again, hopefully all of you can join, can participate in all of the session, so that when we develop the plan, because the plan will really consider the situation in your country. So we expect that all of you can understand the concept, the skills, the software, and other requirements, so that when we set up the plan, it will be relevant to all of us. So I think that's for me to say as the opening. Again, thank you very much. Thank you to BPS, thank you to DOSEM, and thanks to all of you. Hopefully in these 3 days, we will have a fruitful workshop, a fruitful discussion. Thank you very much. Pak Eka.
Thank you, Panang. Okay, the next opening remark I will give to Pak Ali Said, Director of Statistical Analysis and Development. Pak Ali Said, the floor is yours.
Thank you, Pak Seka. Distinguished Head of Statistics Division ASEAN Stat, ASEAN Secretariat Mr. Anang Laksono, distinguished Ms. Jamalias, Director of Integration and Data Management, Chief of Core Team Big Data Analytics Department of Statistics Malaysia, ladies and gentlemen, and very good morning to you all. It is my great pleasure to give the opening remarks in this capacity building in big data utilization. And it is my privilege and pleasure on behalf of BPS Statistik Indonesia to welcome you all here today in this virtual training workshop. I'm very happy to see that all participants from ASEAN member countries are enthusiastic to join this event. And this workshop, which is organized by ASEAN Stat in collaboration with Statistik Indonesia and Department of Statistics Malaysia, is a part of our commitment to develop social capacity among NSO of ASEAN member countries. This workshop is also a form of Pps SASIC Indonesia's contribution for the ASEAN Help ASEAN initiative. Since last several years, Pps SASIC Indonesia has been developing the use of big data for various purposes, such as providing new statistics, producing information to spot for official statistics, and probably for replacing certain surveys, and in the long term, to produce official statistics. Ladies and gentlemen, clearly the world is a very different place today, where we have had the COVID crisis, leading to a profound impact on economy. Given this condition, the increased use of potential big data in tackling some of many immediate problems and challenges precipitated by the crisis also improved in all countries. Ladies and gentlemen, working on big data with high volume, high velocity, and high variety is not easy task. Despite some opportunities of big data that we may have, we may also face other big challenges in its utilization. With a variety of big data sources coupled with big data types, as well as a very rapid rate of big data growth, we need a special skill in big data management and analytics. To address the complexity in handling big data, this training workshop is designed by dividing into two streams: big data scientist stream and data engineer stream. Each stream will consist of 3 parts, and each 3 parts would be 3 half-day workshop. And this training workshop is also designed by combining theory and hands-on in order to provide participants with a good knowledge in big data in both theory and practices. Ladies and gentlemen, I believe through this initiative, we can share each other in big data utilization, and we can learn each other from ASEAN member countries' experience. I hope this initiative will strengthen the relationship among NSO of ASEAN member countries, improve NSO capacity in big data utilization, as well as encourage NSO modernization in statistical activities. Once again, thanks to ASEAN Stat for initiating this event and give opportunity for PPS to deliver this training workshop. Finally, I would like to thank you all for joining this workshop, and I wish you a very, very productive workshop. Thank you very much.
Thank you, Pak Ali. The next opening remark will be given by Ms. Jamaliah Jafar, Director of Integration and Data Management at Chief of Core Team Big Data Analytics. Ms. Jamaliah Jafar, the floor is yours.
Warahmatullahi wabarakatuh. Head of Statistics Division ASEAN Head, Mr. Ali Said, Director of Statistical Analysis Management, BPS, representatives of National Statistical Office of ASEAN member countries, and to all participants. On behalf of the Department of Statistics Malaysia, it is indeed my pleasure to express gratitude to the ASEAN Secretariat for inviting the awesome team to share knowledge and experience in this regional workshop with the ASEAN community. Malaysia has and will continue to support the ACSS statistical capacity building. We believe by narrowing the statistical development gaps among ASEAN member states, particularly in the area of big data, will spur wider use of quality data for and decision making with ASEAN. The big challenge for ASEAN is in producing the right indicators that truly reflect the development pace of ASEAN member states. There will also be other challenges. In an age of real-time information, big data, and the Internet of Things, statistics will be the new currency in in doing business. The traditional or conventional slower method of data compilation will soon become obsolete, and we must be prepared to move towards a world of multiple sources of information, offering split-second update and analysis. The issue of data integrity, protection of confidential information, and competitive advantage among nations, businesses, and individuals will be the new topic dominating conversation. Perhaps it is timely for the Asian community to discuss and agree to a common framework in dealing with these pressing issues, and ACSS would be an appropriate forum for this conversation to happen. Likewise, the big data and open data phenomena will have been extensively discussed by policymakers, statisticians, and businesses. The statistical community has recognized the potential for big data as a transformative tool in producing official statistics in a timely and cost-effective manner. The Malaysian government fully supports this initiative because we believe that better data will contribute to a better future for ASEAN and the respective member states. However, big data technology itself is not sufficient to handle the task. A well-planned analytical process and people with the talent and skill are needed to leverage big data technologies effectively. Realizing that fact, this workshop will provide participants with the knowledge and skill relevant to big data utilization for enhancing official statistics. However, this regional workshop is only one of the starting points toward implementation of the Big Data Initiative. The effort must be sustained, and we hope all the participants catalyst to others in their respective countries in utilizing big data. With that, we wish to extend our very warm welcome to you to the ASEAN Regional Workshop on Big Data for Enhancing Official Statistics. Thank you.
Thank you, Ms. Jamaliah Jafar, for the opening remark. Ladies and gentlemen, right now we are going to have a virtual photo session. So I would suggest all participants to turn your camera so we can see your best smile. I will give sign when we start to capture the picture. Give me a moment. Uh, there are three screens, so it will take a few moments to take the picture. Okay, our colleague, please give your best smile. Okay, thank you. Before we start with the main agenda, I would to introduce our trainers that will give their lecture in this first part. It is just a quick share. I will share the presentation. Okay. The following are our trainers in this first part. So the trainer will give the lecture in this week. If not today, they may give their lecture tomorrow or next tomorrow. This trainer are listed in this presentation are ordered based on their training, their material to be present. So it is not based on their contribution or not based on their alphabetical order. So we start with Pastia Pramana. He is in the BPS Indonesia, also associate professor in statistical institution. He is big team leader for 6 years. Gain certified big data analysis from TUV Rheinland, German. Some of his research is related big data analytic and development for public policy, computational statistics, machine learning, and artificial intelligence. Our second trainer is Dhiar Niken Larasati from BPS Statistic Indonesia as well. His specialization and responsibility in big data, especially in data scientist, analysis of big data for official statistic and for about 2 years. The next ada Koswara, BPS Indonesia, subcoordinator of Statistical Information System Integration Division. My responsibility is manage several small team focusing on IT transformation. His specialization is supervising system integration and governance to support big data platform. He's been working in this area for 3 years. The next is Isnaeni Noviyanti. Unfortunately, we don't have her picture. However, this is the information. His current position is functional staff of Statistical Information System Integration Division, responsibility member of Data Management System team, and her specialization is preparing big data platform and its governance 3 years, and at data engineer for 1 year. The next is Puspita Sari, BPS Indonesia, position staff of Statistical Information System Integration Division. His responsibility member of Data Management System team, preparing big data platform and its governance for 3 years, and as data engineer 1 year. The next is Mr. Dhiar, BPS Indonesia, researcher in big data collection and storage platform. Has been involved in official statistics related big data initiative since 2018. The next, Gera Yesa Ermawan, currently in Polytechnic Statistical STIS, and also in BPS Statistic Indonesia. His position, functional staff of Polytechnic Statistica STIS. Specialization and responsibility, he is researcher in big data collection. The next, Muhammad Lukman. He also Polytechnic Statistica STIS and BPS Statistics Indonesia. Current position is functional staff of Polytechnic Statistica STIS. Specialization and responsibility is researcher in big data collection. The next, our trainer is Ahmad Najmi, statistician in Department of Statistics Malaysia. His current research is focused on integrating studies of data science fields, government policy, and healthcare activities through the application of GIS technology. With 3-year experience in big data, he worked closely with core team big data analytics at Department of Statistics Malaysia. Nur Huriatul Huda, statistician as well, in Department of Statistics Malaysia. She had joined core team big data analytics in 2020 and is currently involved in the development of geospatial related analysis. The next, Pak Usman Bustaman, BPS Statistik Indonesia. Specialization and responsibility in big data as data scientist for about 2 years, responsible in data processing and analysis, data quality and governance of big data. Next, Ranu Yulianto, BPS Directorate of Statistical Analysis and Development. His specialization and responsibility is data engineering team. He has experience for 3 years, 1 month in current team. The last one is Muhammad Hanifah Yu Ananto, BPS Statistik Indonesia. Current position, functional staff of Statistical Information System Integration Division. His responsibility, member of Data Management System Team. Specialization, preparing big data platform and its governance for 3 years, and as data engineer 1 year. Okay, that's all our trainers. Okay, we come to the main agenda in the workshop. For this first agenda, it will be brought by Pak Setia Pramana and Miss Dhiar. Pak Setia, I give the floor to you. Can you share?
Yes.
Are you able to share?
Let me check that. Let me check. Screen. Let me check. Can you see my screen now?
Yes,
Did you please?
we can see.
Okay, sure. Thanks. Thank you, Pak Eka. Shall I start or Pak Eka?
Yes, you
Okay.
can start.
Okay, thank you.
Yeah, thank you.
Good morning and Assalamualaikum warahmatullahi wabarakatuh. Good morning, all participants from all ASEAN countries. Good morning, Pak Anang, Pak Ali, and Mrs. Jamalia from Department of Statistics Malaysia. It's a great opportunity for me and for our team to be part of this. I said that this is a really distinguished and extraordinary workshop that we can share the experience on how to use big data for enhancing official statistics. Let me just, before going to the topic, I will repeat what have been said or mentioned by Pak Ali and by all the ASEAN-SAT, Pak Eka and Bu Jamalia, that this is the workshops, and the workshop will be divided into three parts. Data science scientist stream workshop, and then so another one will be data engineer workshop. And for the first 2 days for this first part will be we will have the same presentation, and then the third will be different presentations on Friday. So the first part will, for data scientists, will we will discuss and also share the experience on the big data, and also how we develop big data for official statistics, and also introduction to Python, data management, and visualizations. After that, the second part we expect that will be on June 2020 for data science workshop. Same workshop will be introducing database, web scraping, and also visualization using Power BI. Later, the last part, but not the last activities. I'm sure that Pak Anang mentioned that after this workshop we will have other continuation of these activities. The last part will be on Google trend analysis, and also data mining, and also supervised learning using Python for data scientist stream. For data engineer, I'm sure I see the list of the participants. There are some basically based on the IT, and the other one based on the statistics. So data engineers workshop will be more or less the same like data scientists, but there's some focus on data engineering. As you mentioned, as you see that here, the part one for the last day will be on Friday. We will have introduction to data engineer, which will be delivered by our data engineer team led by Pak Ade Koswara over there. And then for the second part will be the same, that introduction to database, and also web scraping, web crawling using Python. And then for the third day will be different, more on data processing using Python. And then for part three, this will be totally different with the data scientist stream workshop. For part three, will be more on big data software and platform, and also some experience, and also maybe some possible demo on Hadoop distributed platform and visualization in production environment. And there are some case studies will be delivered as well on the part three. Hopefully, if you have any question regarding this, you can raise and then we can discuss that later. So these are some already mentioned by ASEAN-SAT. That's our trainers from Indonesia. It's as you mentioned also by Pak Eka. We have colleague from Malaysia will also share their expertise as well. So for this morning sessions, hopefully it is very big day, and then also you can see what will be coming for this workshop. So the first day, it's more or less on how big data and also data science are related. So more introduction of data science, and we will give some example of our implementation of utilizing big data for official statistics by my colleague Dhiar, Niken, Larasati. I skipped this. It's already mentioned by Pak Eka. So I'm pretty sure all the participants have experience or have heard about the big data quote unquote terminology, right? And then there's some feedback here. Could you please? Okay, thank you. Okay. So big data, we have some fees that 8 fees, value, veracity, and etc. But actually, this is the idea of based on ITU. Big data is a paradigm for enabling the collection, storage, management, and analysis, and also visualization, and hopefully we expect under real-time constraint with different characteristics and heterogeneous characteristics or type of data. That's type of big data. So this when we see big data, it's not about only the volume itself, but also related to different type variety of the data. It could be structured data and also unstructured data. I'm sure that for all of us come from National Statistics Office of our country, we are already experienced with structured data. But now the technology have increased rapidly, and we now deal not only on structured data but also unstructured data. So the activity of the big data will be related to capturing, storaging, processing, sharing, and reporting. And this, as I mentioned before, this is above or beyond the ability of previous software tools that have been known in a couple of years before. And the thing is that when we see big data, it's not only one type of field that are working on this type. Usually we learn about statistics, right? Only statistic. But now we have what's so-called data science field, which actually a combination of several fields, let's say from statistics, data analytics, and then computer science, and then other things, with which will make a term of data science. And then inside this data science, we will have some machine learning process, and also possible of artificial intelligence, and also IoT, and also other technology. And the expectation of this big data, we have to have efficient and cost effective, and also faster and accurate decision making. So this is actually the main goal. We don't, when we have big data, but we just produce a publication of our national statistic 2 years or 1 month, but with data, that's not the big data. Just like ordinary or conventional statistics, right? We expect that by having this big data, we can have a faster, efficient, cost-effective, and accurate data, so we can give accurate and faster decision making. So of course, the big data will see that the number in the table left hand side, you see that some gigabyte, terabyte, petabyte, and zettabyte data. Just some zeros over there. The next slide I will explain. I will briefly overview or visualize how big is that. But as comparison of the big data in 1990, that we usually store about like 1 gig is already big, right? And then the transfer speed is only 4.5 megabyte per second, and read drive is about 5 minutes. And 2010, the storage up to 1 terabyte, and the speed is up to 100 megabyte. But now the technology and also the technology and also the demand is getting higher and faster. So with the Hadoop, we can have hundreds of drives working at the same time within minutes. So how large is big? So maybe there are some question on how big. So for illustration, if you have 1 grain is 1 byte of data, so 1 kilobyte is 1 cup of rice, and then we have 1 megabyte is 8 bags of rice, right? If we have 1 terabyte is similar with 2 container of ships. One ship already blocking Suez Canal. That's a problem, right? This is already 2 container ships, and then 1 petabyte. All the grain of rice will cover Manhattan, right? That's how to illustrate the size of the data, and how this data can have a problem with if we don't handle it carefully and also effectively. So this is for main phase of big data, the volume. So the volume, this because of the volume of the data so high, because of the streaming of the data, so the velocity, the generation of the data, there's some data coming for milliseconds and days, yeah, and then hourly, right? So for example, events on speech or social media or other information that come from sensors. And the variety of data comes from, it could be like structure. We expect we know the table, the one of structures, unstructured from text, for example, from videos, from speech, and for other type of data. And then the veracity. This is the main things I think I have to bold because we are working now. We are more all of us in national statistics, which have to provide valid information, right? So though we have a large number of data, large variety of data, and then the velocity of data is very fast, but the main things we have to make sure of the data that we can get actually can be trusted, because only few of the data can be trusted because of some maybe it's not based on the true. It could be some misleading. There's some fraud related to propaganda and etc. So these are more the main characteristic of big data. So this is several type of big data sources. There are three types: exhaust data, sensing data, and digital content. So exhaust data comes from digital activities of people, for example, mobile phone data, financial transaction, online search, and also our postal data. And we have also sensing data. The data comes from sensor, comes from medical devices, come from tools, come from other device, for example, biometric data, Internet of Things, connection of the things that are connected to Internet, sensors, and satellite imagery, and other example of the sensing data. And the other type of data sources is digital content. This comes from information posted in the website, right? For example, social media, web scraping. We will more on the web scraping discussion during this workshop. Participatory sensing, which is crowdsourcing. We get data from information from a crowd, from people, health record, radio content, and etc. So the first two data sources, exhaust data and sensing data, they are measuring what people do. So this mobile data, how how people are moving around, what they are talking about, we can get the content, and how the transaction based on the financial transaction. That's what people do. The same thing with sensing data, biometric data. If you know now, because of COVID, we heard more on PCR or NGS, next generation sequencing, which actually the size of the data is so high, also so big, that measuring what is happening inside the body. So that's what people do, right? Moving around or moving something, for example, sensors of flying, of flights, and also sensor of buses, etc. And then the digital content, this type of data sources, this measuring what people say or what people think in mind. The difference or the veracity of digital content is very low, right? The quality or the truthness of the digital content should be considered carefully, because it could be propaganda, it could be deceptive, right? It could be that not correct one. So we need really to be careful to take care of the digital content data. So all the data that we have, we plan to do the analytics approaches, right? So this is the step of the analytic approaches. We start with descriptive approach. So we try to understand what is happening or what happened in the past, or what is happening right now. That's descriptive. And then once we know what is happening, we try to go further than doing what is happening. Why it's happening right now? So why did it happen? That's a diagnostic approach. And then the next step is to have some predictive. What will happen? And what will happen under various conditions? We try to give some different conditions. Maybe we can predict what we expected outcome of this condition. And then the ultimate analytic approach, which actually we need to go from descriptive, diagnostic, and predictive, is to prescribe. So to give information, or to try to give or to provide what type of options to create the optimal or the high result of outcome. So this is a kind of correlation or association between big data and data science, right? So in big data, we have quite a amount of data, and then we don't worry again about the number of data, because data is there everywhere. The structure is quite diverse, and the volume and also the speed is very fast. But then we need to make this data into information, right? So the analytics come for this part. So the analytic is related to how to discover, to interpret, and to communicate the information and the patterns that from the data. So this process include uncovering the hidden patterns and try to understand unknown correlations, and then to extract other useful information that maybe we expect can help organization. In our case, it could be government or a citizen for their decisions, right? So the activity is of this data analytics is mentioned by data science, so to extract information and knowledge, and then this combination between math and statistics, and also information system, IT, business case, and etc. And big data can be very fast, complex, and also the information quite diverse, from CCTV, vlog, it could be podcast, it could be TikTok, it could be other things, historical data combined with our official data will be good for having a more deep and also more high quality of data analytics. And then related to, we can also have some social computing, quantification of social and human behavior. For example, for market segmentations and fraud detection and purchase behavior and also brand awareness, and etc. So this is the hierarchy of data science. So we start with data collections, which include the instrumentation development, a sensor providing, getting the data, and also user-generated content. And this is usually developed by software engineer. And then the next step is to collect the data and to store the data. And this is usually done by data engineers to make sure there are some good, reliable data flow from the data, and also the storage, the place, and then make sure the infrastructure are running well, and also can be streamed daily or weekly, or cannot be stopped, and to make sure the storage of unstructured and structured data nicely, and provide ETL, extraction, transformation, loading to the next step is to cleaning, and also to find the anomaly detection, to find some anomaly from the data. There's some maybe some hoax from the data. That's including the pre-processing step. So all the steps usually is done or is responsible of data engineers. For the data stream, more you will focus on these two or from the data collection steps. And then after the data is being processed, and for your information, the first and the second up to the third step, exploration, is maybe 70 to 80% of the total work of the data. So actually this step is really laborious, and then need to be carefully done. Otherwise, we'll end up with very bad quality of data. And once we have good data or all pre-processed data, we next to do the analytics and some aggregation and the feature selection, and then some simple machine learning algorithms that being done by data science analytics. There are some cases that include the AI and deep learning, which usually performed by research scientists. Usually is done by student of or for PhD level case for developing AI and deep learning in advanced analysis. So the different of data engineer and data scientists, and there are some, as I mentioned. And then these are some languages, tools, and software by, for example, for data engineers, you have MongoDB, Postgre, Hive, and then in between the connection between the data engineer and also data scientist will be, you have Hadoop, Spark, and other platform that will be discussed by our colleague from data engineer team. For data scientists, these are some tools and software that usually being used, from example, Tableau, Pandas from Python, SAS or R, Python, right? GMP, that's for social media, RapidMiner, Excel, of course, or ggplot for MATLAB. But for us, for this workshop, we'll more focus on Python. Of course, we cannot do also for R, but if you do both, it will be confusing. So for this workshop, we'll use a Python, and then Pandas will be discussed next tomorrow or the day after tomorrow, and also some of Matplotlib for visualizations. And then for the first, the second part will be we'll discuss Tableau for visualization and also Power BI for visualizations. And for data engineer will be also discussed on Hadoop, Spark, and etc. from data engineer workshop. So this is the criteria of big data team. So of course, if you look at these, the criteria is quite challenging to find this type of people. And if we have that of people, I'm sure they will prefer to work on the business or they prefer to work on the private companies, because now the salary of data engineer and data scientist is quite high. So to have this team, of course, there are some essential program and technical skills that are needed. You can see this start from data engineer, Apache, Hadoop, and Amazon service, Azure, etc. Of course, we also need a technical skill, SQL, and also ETL group tools, machine learning, Python, and also some knowledge of algorithm and data structures. But we also need soft skill to communicate this information, to communicate the data, the system, and to collaborate with data scientist team, data analysis team, and also to present all the information to the stakeholders. Similar with data scientists, the essential programs need to be obtained by data scientists is Python and R, for example, and also SQL, and also some machine learning and AI procedure. The same is to visualize and also business strategy and machine learning and AI. Not only communication and collaborations, the challenge of data scientists is to make sure the data and the information has been resulted through all the laborious process can be explained to the users, right? So skill of storytelling and learning new thing is important for data scientists. This is the body of knowledge of data science. We have data analytics, data management, data engineering, business analytics, and research methods, and project management. We focus only on data analytics and data engineer for this. So data analytics consists of machine learning knowledge we need to know, and data mining, statistical methods, computational modeling, simulation, text mining, graph analysis, and also business analytics. If you look at all these knowledge that need to be or we expect to have for data scientists is quite diverse and quite hard. Understanding statistical method is quite challenging. Having or adding data mining and some machine learning, that's another level of challenging approach. But those information need to be acquired by data scientist team. I said team. Why? Because I'm sure that not all of us can understand all this information. In BPS, for example, usually that text mining, we have a group of team that focus on text mining, and another one is on graph analytics, and some people are focused on statistical method, and we have research group on machine learning and data mining. And then usually we collaborate with other division on business analytics related to some modeling. That's another statistics and also methodology department of that. So data science is not only 1 or 2% knowing or understanding all this information, but instead this is a team that can collaborate together and they know all these informations. And this is the data engineer knowledge, including the big data system, organization, engineering, infrastructure and platforms, big data infrastructure and technology, and then data and application security, because we have all the data comes, and then to make sure the security and confidentiality are kept. And then the cloud computing technology for big data and data analysis, because for information, most of the large company that working on big data, they don't use on-premise infrastructures for their computing technology. Usually they use a platform, a cloud platform, because it's easy to use and then can be implemented easily, and then it's perform well, and then we don't need to it's quite cheap as compared to on-premise, but then that depends on the situation of the companies. And also data science apps design, and then information system to support driven decision system. So this the big data related technology and also methodology, artificial intelligence. For the last part of data science, we'll discuss on much simple machine learning. It could be unsupervised and supervised learning, and then that's simple data mining. But all this information need to be acquired by data science teams. It could be not only one person, but it could be one team working on data mining. Another team is on social media analytics. Another one is on video or text analytics. This is example of artificial intelligence. We have deduction, resonance, so knowledge representation, planning. For the last part, we'll focus on machine learning. As I mentioned, we'll discuss on supervised learning and supervised learning. Reinforcement learning, we're not going to discuss that, but if any question that we also can give that. But supervised learning, including decision tree, association rule, for unsupervised learning, including clusterings, and also similar and metric learning that will be given on the last part of the workshop. Part 3. There, we have the data, right? We have the technology there, but then this is the main challenges of the data. First is to access the data access. Not all the data can be accessed easily, not all, as mentioned, because the data now is being they are being owned. They are owned by a private company. For example, data of marketplace, data of Uber, for example, travel agencies that owned by companies, right? So we need to have some discussion or collaborations with them to get access. And then the second is data privacy, right? So the privacy, because we get mobile phone example, we get the mobility of this person. How to make sure this data cannot be reveal the person activities, one person activities. And then the next challenges is to find the best and also suitable algorithm based on the characteristics. When I say algorithms, it's not only focused on the quality and also the accuracy, because all the data, this is threshold. There are some threshold within data accuracy and also the speed of the analysis. Usually we want to have accuracy, but takes time of having that. And also we have to find the evaluation, and also we have to find the best algorithm of different type of data. And then, as I mentioned, speed and accuracy. And then to find the scientific equations and also the hypothesis. And the challenge is to find how to make sure the data comes really fast and also in the nice way, streaming data online. That's also another challenge. You have the data comes weekly. That's not that fast. It could be daily. It could be hourly, and then we can provide the analytics in real time as well. That's maybe that's uh, not that common in conventional statistic. Usually we get from sample from information from field, right? And we do some data analytics, and then we publish it during a couple of weeks or months after the samples. We don't do real-time analytics. But right now, with all the data, we have to go to real-time analytics. We don't need to wait for 1 or 2 months. We expect to get information within within days, so we can also provide the data in real time. And the challenge is data quality, right? Because the data comes, it could more, they consist of unclean data, they consist of information that not correct, and then we have to make sure the information, the quality from the data can be accessed and can be obtained. The difference between the conventional or previously approach data quality, usually we will make sure the data obtain similar what we expect, or the questionnaire and also the way we ask is good, right? But then now the data comes with their problem. We have to split, we have to clean up all the problem after data comes to us. That's challenges that we have been faced for a couple of years when we do this big data analytics in BPS. And then the last challenge, which is actually the main problem, I'm not sure. I'm pretty sure for all the ASEAN countries, it's too hard to find the right talent. It's not only for a national statistics office, but it's also for business and also for private companies. They always discuss with us, with me as well as privately, how to find the right talent, because knowing all this information is another challenge, and to find the right talent, the right person to understand and can run and also can do all this hard and so fast analysis is difficult to find. Right now, there are some universities that changing they're adopting their syllabus. For example, Polytechnic Statistics, we have data science program, and also there are some university in Indonesia and also I think Malaysia and also Singapore and also other ASEAN countries have a university that already adopting data science syllabus and changing bit from data science, from statistics to data science, or from IT to data science department. And now is big data for office statistics. I give my the floor to Dhiar Niken. Can you continue, Dhiar, to explain the big data for office statistics?
Okay, thank you, Pak Setia, for the presentation. And I would like to continue our material for today. Let me share the material first. Okay. Okay, I hope you can see the screen well and also can hear my voice clearly.
Yes, we can hear you clearly.
Okay, thank you. Okay, we will start for big data for official statistics. As you know, big data came with great promise for official statistics because they can enhance and also strengthen official statistics as well. Big data have several potential complementary roles, as we can see here. The first one is providing variables to help us stratify better for our sample survey. And also big data could improving sample survey estimates. It's usually used as weighting or ratio or regression or imputation or etc. and it's called auxiliary variables, which we do not need to be perfect. We just need big data to be correlated well with our primary variables of interest. And the third one is big data also helping us to compensate for non-response and helping us check whether our estimates already fit or match to the reality or phenomenon, because big data can capture the real-time condition of the things that we want to analyze, like the economic or the social condition. So it helps us to check whether the estimates that we have already fit or match to the reality. And also it's helping us improve the frequency and timeliness of our data releases. And the last one also improve and provide more small area estimates, because the characteristic of big data, it has a big volume and also scope. So it's not impossible in future we can use big data as usually variable for small area estimation. Okay, so here are several comparisons between official statistics and also big data. As we can read here, the official statistics are structured and plain product, while big data are unstructured and unfiltered data, because usually big data are driven as byproduct of digital product like transaction, website, social media, sensors, pictures, and etc. The second one is official statistics have a clear concept and methodology, while big data have a poor analytics, because we cannot use a statistical method to analyze big data. Official statistics also have a clear regulation, while big data, as Pak Setia mentioned before, Mr. Setia mentioned before, big data is unregulated and mostly have privacy issues like confidential information of internet users and etc. And the next one, official statistic cover macro level, as we know. So we could make inference for population from the estimates that we have, but we cannot do that for big data. Big data are micro level, but it have high velocity and also variety. And official statistics are also costly, as we know that we need budget to conduct surveys or census, but when we use big data, it mostly near free or have no cost. So it's quite cheaper than official statistics. And the last one here, official statistics are centralized and usually describe only one point in time, but big data can describe, can give information real-time condition. Okay. So here is the examples of big data for official statistics, the examples all over the world. Okay, we could see that here we can predict poverty and wealth from mobile phone metadata. We could there also paper that say mobile phone data could replace census questionnaires in UK. Mobile phone cell data as a regional social economic proxy indicators, and mapping poverty using mobile phone and satellite data. Here we can see that we could use what we call CDR, or call data records, to predict poverty. In CDR, or call data records, we could get like history of interaction of the user using their phone, the duration of the call, and the billing phone, etc. And we use it, we process it into the information that benefit to predict poverty. Or we could also use like satellite imagery data, like nighttime light, to predict poverty. So we can see from the satellite image which area have more light, brighter than other area. It means that the area have a brighter than other area, means that that area are prosperous. Yeah, something like that. It's also other paper that we could see that we can use big data for price statistics. In example, we using e-commerce data to predict the price and also to predict the sales in the market. Also, we can use MPD or mobile positioning data to predict foreign visitors inbound, outbound in border area. And also we can use big data for sustainable agriculture using geospatial cloud, as we can read here. But even though big data have not been implemented as official statistics, yet we know that the usage of big data are already exploited to support current official statistic, and it's not impossible that in the future we can use big data for official statistics. Okay. This is some of the answer why big data right now are not used as official statistic yet, because there are some pro and contra of big data. We can see here the pro of big data for official statistic. We know that big data have a faster and frequent dissemination of data. It could respond the great relevance to the request of the user, and then it could refine the existing measurement, and it's a substantial reduction of non-response rates, and it may considerably reduce the cost of the statistic production, because we don't need any money to collect the data for big data. But there are also contra of big data for official statistics, like what I said before. The data are not the result of the statistic production, so we cannot calculate the error or the how many percent we can trust the data of big data, and they do not fit the current methodologies or classification or definition, and there are so many complex pre-processing to process big data into aggregate value like GDP or CPI, and it takes time and takes knowledge, and it's quite difficult to process big data into indicator that we use today, that important indicators that we use today. And it raised many major legal issues, like what I said before, about security and also confidentiality of the data, respect for private lives of internet users, and data ownership, and etc. Here are the challenges using big data. We will face about the data quality, sustainability, and many type of big data do not represent random sample of the population, because we don't use sample design to collect big data. We only collect all the data we can get in the internet. So we do not use any sample design, so it cannot be used to inference the population, like what I said before. And also we face a challenge to access to big data and to capture data, and also data storage. And we also need a multidisciplinary skill to strengthen the team, so big data can make sense and can be more benefit to us. Okay, here is the Pps Big Data Team. Currently, Big Data Team is under Directorate of Analysis and Statistic Development. This directorate is responsible for the big data development in BPS, and we have data scientists and also data engineers here to ensure big data analysis are produced well and disseminated every month to other division or stakeholder. We make sure we can analyze the data well to stakeholder and other division. But in the process, we collaborated with researchers in universities, and currently we are working with Polytechnic Statistical SAIS to get advanced algorithm. You can see here, we collaborate with researchers in universities. Right now, we collaborate with Polytechnic Statistica SAIS. And we also work with other directorates. We work with Directorate of Statistical Information System in terms of building the big data infrastructure, and they also have a data engineer to collaborate with our data engineers in terms of data acquisition, pipelining, and also data management. And this figure want to show us the big data process in BPI. We start from the requirement to adapt with a new condition now in this disruptive era. We know together that we are still facing COVID-19 pandemic. So we should meet the requirement to produce fast and near real-time analysis to help government and stakeholders know the current condition in Indonesia. So we try to use big data to provide fast and near real-time information. And in 2020, we have several topics in big data. Here we can see that we have e-commerce data. We also have flight status data, air quality data, job vacancies, and also tourism and accommodation data. We got all the data using a crawling technique with Python software or Covex Kapal for some cases. And after that, we do some pre-processing to get a clean data and also analyze the data. We also build a dashboard, so high level or other stakeholders or other division could see the analysis easily, and so they could see the impact of pandemic in several sectors and make a policy that proper and that relates to the condition. So far, these are topics of big data that we are currently working on. We have what I have said before. We have social media and news data, mobility data, job vacancy, online booking data to get that accommodation, and marketplace data to get e-commerce data, environmental data to get air quality data, air quality index data, flight and ship tracker. Also, we are try to explore satellite imagery and mobile phone data right now. Here are some examples of big data analysis that we've done in BPS. The first one is Google Mobility Index in grocery stores for daily necessities. We could see here the positive value indicates that the activity in groceries are higher than the baseline. What is baseline? Baseline is a condition before the pandemic. So the positive value indicates that the activity in groceries are higher than we usually do before the pandemic. Otherwise, the negative value here indicates that the activity are lower than the baseline or than the time before the pandemic. So from this figure, we could see that in August 2020, it can be assured that people mobility in grocery store for daily necessities is back to what it was before the pandemic period, because the value is near zero. It means that the activity is likely to back to what it was before the pandemic. But it has been declined after the social activity restriction policy in January 2021 because of the active cases of COVID-19 are arise. So the government make a policy to restrict social activities, and it makes the activity in grocery store are declined or lower than the baseline or lower than usual. And the second one here, we can see the flight data. It's the number of departures flights from Soekarno-Hatta Airport, the most busiest, the busiest airport in Indonesia, Soekarno-Hatta Airport. We can see that the number of departure flights from Soekarno-Hatta Airport increased in July and August. The number of domestic departure flight from Soekarno-Hatta increased in a new normal period, because it's not so many restrictions in the new normal period. It makes the activity of the flight and transportation is back to normal, but it's still lower than the activity before the pandemic. So it's other analysis for e-commerce data. Yes. Yes.
Go back slide, please.
Okay. Wait. This slide?
Yes. I wonder how we can collect the daily necessary data.
Yeah, we collect
Is it
data.
Is it a Google data?
Yeah, it's a Google Mobility Index. Is that the data that you want to know how we get the data, Google Mobility Index? We can get the Google Mobility Index from the website. Google has already share it free. If you want to get the data about the mobility, we can search it in the Google Mobility Index.
Thank you.
We can get it free.
Thank you. I sure.
And we can download it.
Yes. Thank you.
Okay. Can I continue to the next slide? Okay, I will continue. Okay, the next analysis is e-commerce data. We could see here in pandemic era, the sales in e-commerce are increased. It means that people are shifting from traditional market or on-site market to online market to avoid physical contact. So people are prefer to shop from home using online market than to go to the market to buy their necessities. And we can see here that the care and beauty have the biggest sales in marketplace, and follow with health like supplement or medicine and etc. And the next one is job vacancies. We could see that the number of job vacancies has been declined since the beginning of COVID-19 pandemic until the new normal period. It indicates that the decline of the economic activities during the lockdown. The decline of job vacancies can be a proxy to indicate the decline of economic activities during the lockdown. It's other big data that we are currently exploring. We have mobile positioning data. Here, we use mobile positioning data for tourism statistics in Indonesia. Since 2018, BPS has had MOU and contract with MNO or mobile network operator. We have MOU with Telkom here regarding the use of mobile positioning data for official statistics. In example, for domestic and outbound tourism statistics. We use the BTS location to predict the area of the visitor. And right now, mobile positioning data is used for international visitors, domestic tourists, and mobility between region statistics. And the next one that we are currently exploring is satellite imagery data for predicting poverty. Here are the satellite imagery data process. I will explain a little about the process. Here, after we input the image, we break down the image into smaller grid and then convert the image into specific value or number based on the RGB code. Then we train the data to know whether the grid is matched with our condition or not. Let's say we want to get a grid with yellow color because yellow color means that the area are prosperous or have lower poverty rates. Let's say like that, because yellow means that the area are brighter. They have so many lamps and light, and it indicates the activity of economic of the area. So we assume that yellow color means that the area are prosperous or have lower poverty rates. Then we want to get a grid that have a yellow color. The more yellow, and then the more prosperous the area. And let's say if we
I cannot hear Dhiar voice, but can you hear?
I think her voice is broken.
Okay, D, can you please? Dhiar. So
okay. Hello.
yeah, maybe the
Hello.
connection, Dhiar. Yeah, the connection.
Uh,
Yeah. Please, you can
Can you hear
start.
my voice now?
Yeah, no, it's okay. Can you please start over on startlet imagery? I think.
Sorry, I would like to stop share first because I cannot hear the voice. Sorry.
Yeah.
Okay, hello. Can you hear me well now?
Yes.
Yes.
Okay. Okay, I will move here, but I'm sorry, I cannot turn on the camera because the PC have no camera. Is it okay?
Yeah. No
Yes,
problem.
we are
Okay.
fine.
Okay. So I wait. I will continue. Okay, we are here. Okay. Uh, can you tell me which part you cannot hear well, so I can explain it, re-explain it about the data process.
Yes, I think we can start with data process.
Okay,
Yeah.
okay. I will start with the data process. Okay, so here are the satellite imagery data process. I will explain a little about the process here. After we input the image, we break down the image into smaller grid, and then we try to convert the image into a specific value or number based on the RGB code, so we can train the data. We cannot train the picture data, but we can train if we convert it into a quantitative value. So we train if the grid that we have is matched with our condition or not. Let's say that we want to get a grid with yellow color because we assume that area with yellow colors are the area that are prosperous or have low poverty rates. So that area are brighter and have more lamps, lights other than other area. So it indicates that the activities of economy is well doing great on that area. So it means that it have a low poverty rates, let's say like that. So we want to get a grid with yellow color. Then we try to train the grid if whether the grid is yellow or not. And let's say if the grid cover with yellow color, it has a value 200, let's say like that. So we want to try if our grids have a value near 200. Then we train. We could see that our grid or our picture is prosperous or not. The area is prosperous or not based on its values. I hope I hope my explanation is can be understood enough for you. But if you are not if there anything that you want to ask, you can ask later. I will next move on to the next slide. Is Google Maps. There are at least two methods to collect the data from Google Maps. The first one is using API, and the second one is using web scraping. From Google API, we using a Python language with a package with a certain package like request and URL lib. From Google API, we try to collect village office coordinates and also try to collect infrastructure around the village office, and also try to collect the village office to know the distance of village office from other infrastructure. And the second one is using web scraping. The data was collected using a scraping package. We also use Python using a certain package called Selenium, and similar with Google API, we also try to get a village office URL location, and also infrastructure search URL data, and also we try to get detailed infrastructure data. And here is the implementation of satellite imagery data and Google Maps data. For satellite imagery data, we use satellite imagery to measure the density of economic activity in the area, like what I have explained before, and also for land use and crop choices, poverty mapping, infrastructure penetration, economic growth, building types, whether the area is covered with residents or covered with companies, high building, or etc. And from Google Maps, we try to update area in terms of public public facilities like hospital, schools, etc., etc. And we try to analyze for the case of accessibility of the public facilities. Is it easier to get there or not? And also we try to analyze the economic growth from Google Maps, also number of visits and sentiment of the location. We can see from the comments of the Google user whether the public facilities is good enough or not, how the facilities, how the service. We could see the sentiment of public for the location. Okay, the next data that we have is a financial statement IDX. Here are some of the process of financial statement IDX. We get the data from the IDX web. IDX is Indonesian Stock Exchange. So we get the data from the website using crawling technique, and we store it in data management system or data lake. And after that, we make a pre-processing to get the company identity data and to get balance data. So after we get the balance data, we can use it for national accounts to help them support them build HUT or FSA. And what we get from a financial statement data, we get general company information, and also we get statement of financial position and statement of profit and loss and other comprehensive income, also statement of change in the equity, cash flow, and etc. as you can read here. Yeah, so it is the dashboard that we have for IDX company financial statement, but the dashboard is still in the Bahasa, but I want to explain what we have in this dashboard. We can get the information about statement of profit and loss by sector and company here, and also earning per share, and also it's the profit and loss by companies. And also we can filter the data by time period or sectors or subsectors. The next data that we have for big data development is environmental data. We get the data from aqr.com and also power.larc.nasa.gov. From aqr.com, we have variables about air quality index like air quality index, also air temperature, air pressure, wind speed, and humidity. While from power.larc.nasa.gov, we get data related to the rainfall, like the rainfall, temperature, humidity, wind speed, and etc. You can see here. And we use the data to know about the quality of our environment in Indonesia. We also have written some publication. So far, we already have 4 publications. You can download it in www.bps.go.id. We have the big data for COVID-19 impact, and also big data in new normal condition, and also big data for economic statistics, and big data for social statistics. We also have a social media of Big Data BPS. We have Facebook and YouTube and Instagram. If you want to know more detail about what we have done so far in BPS, you can just visit our social media here, Facebook, YouTube, and Instagram. And the last one, we also have written some scientific publication. Some of them are already published and some of them is still in the process. But I hope it could have a benefit for everyone that read it. Here are the scientific publication that we have. Okay, I think that's all from me. So I will give the time to Pak Setia, or maybe
Yeah.
Okay.
Thank
you.
Thank you.
Tapi-
Dhiar.
Minggu ni Isnin dengan Selasa tak pergi.
Aduh.
Sebab kena ada meeting pukul 8 malam.
Shall we wait until? Okay, thank you. So that's our presentation. So we hope that there are some insight that we can give to all the participants. So we still have 25 minutes of presentation of the time. So maybe we can have some discussions from. Is there any questions from participants? Please let us know. Or if you don't have any question, shall I ask you? Because I want to know also all the participants what all of you are working right now and what types of data or big data are dealing with. Maybe we start with some questions.
Setia, can I have one question?
Okay, yeah, Pramana. Yes, that's for me or for Dhiar. For Dhiar, Dhiar will answer it.
Yeah, either you or Dhiar.
Oh, Dhiar. Okay, so
Either you or Dhiar. Yeah. On the slide 22, I forgot. Maybe it was you, yeah, who presented slide 22. On the challenges, yeah.
Dhiar, slide 22, Dhiar. Please. Yeah.
So considering those challenges, yeah, the challenges are in many aspects, yeah, in various aspects. So at the current stage, at least in BPS experience, when you conducted initiative or study or activities related to big data utilization, is it data driven or needs driven? Yeah.
That
So
is,
you,
yeah.
That's my question. Thank you, Pak.
Yes. Dhiar, me or you, Dhiar?
I think
Okay.
Pak Setia.
Okay, so that's very good. So in our experience, we can start with, of course, if Gsbpm, we always start with needs, right? We try to find the needs, and after that, what type of data, how we collect the data, and etc. Right? We can do that way. So we try to, okay, what is the needs? For example, we need to find information of companies and their report, financial report. So which website we can get, right? So okay, that IDX website, that's example of that that direction. But either way, we can do we can have also, for example, we have already the data. So from this data, what we can extract, what type of information we can obtain. For example, the data of mobile phone, or data of social media, for example, simple social media, right? Social media, there are some ways you can extract freely, for example, from Twitter or from Instagram. But then based on this information, based on the structure of data, variable of the data, we try to find, okay, this information might be useful for this type of data or for statistics. For example, Instagram, and also information of Travelog, like Agoda, Travelog, etc. Travel agency, we try to find, okay, we can get the data, and then based on this information, we can infer, or we can have different type of statistic of tourisms, and also other statistic price, and etc. The same like mobile phone data. Mobile phone data, we can get the data, and from this data it can be extended to many applications. Can be for not only for tourism purposes that have been done by BPS. It could be also for mobility, for poverty proxy, for demography, for other purposes. Satellite imagery, we try to, this is one of our focus of research, to get the to understand how to deal with satellite imagery. We have a team. Actually, now they are having usually we have a Wednesday discussion on satellite imagery, and then based on this information, we try to find which type of statistics that can be developed based on this type of data. So either ways, but you can both from needs and also from the data. It could be both ways.
Yeah, thank you, Pak Setia.
Yeah, but the main thing is you get the data first for me. Once you get the data, it's nothing you can do with that. Any other questions?
Yes, I have a question.
Okay, can you from
Vietnam.
Mr. Who?
I'm Hưng from
Hong.
Vietnam.
Oh yes, Hong.
Regarding to data privacy, I think it is a big problem when we get big data from the internet or website. And could you share to us some experience from Indonesia to get the data from the website? For example, in the advertising advertisement website or the online website. Because when in Vietnam, when we access to the website to collect the data, we have up to now we don't have a legacy platform for get data, and the cooperation between the statistician or from the researcher with the data owner. I mean the website owner is not good, so it's difficult to get the data. So please share the experience from you. Thank you.
Okay, thank Mr. Hong from Vietnam. That's it's only for it's not only challenge for Vietnam, but I guess that's for all countries, not only ASEAN countries, for all countries. Legality and also confidentiality, that both things that goes hand in hand. So legally, how we can get the access legally from the data owner. So for related to data web scraping, there are some website that provide information. For example, data that they explain how whether we can access it, with what type of data we can access it. Usually there are some robot TXT data. So we usually, based on that information, we follow the instructions so we can get the data. And usually, after we follow the instruction, we have we are also shall talk or discuss with the website. So right now we have already a regulation that all the information from marketplace or e-commerce, not only marketplace, e-commerce, should be reported to BPS based on our regulations. So actually we have some regulation related to that, but the regulation is that's still that's already there, but now we are still having on that technical regulation on how to do that. And related to confidentiality, we get the data from MNO, one of the biggest mobile network operators in Indonesia. So to make sure that the data are still on confidential, we can only have the data of sample data, and all the informations related to the numbers and other information are kept. They are being harshed, so we cannot get information of the data. So, and the analysis is being done in their server, in this mobile network operator server. So it's not in our server. So to make sure the confidentiality is still kept there. I hope that can answer the question, but again, still confidentiality and accessibility, legality, all those are still the main problem, or the main challenges, not problem, challenges for having big data. That's why we, our team, encourage data partnership between national statistic offices and also the private sectors. I think we have, I don't know, Pak Ade here, Koswara, maybe you can explain. We have initiative of INDA that's trying to connect between different data owner and BPS, and also for Indonesian government. I think that's my answers. Pak Ade, you want to discuss about the INDA, Pak Ade, or will be after this, right?
Yes, maybe for next session, Pak.
Yes. Yeah, good. Thank you. Thank you, Mr. Hong. I hope it can be answered.
Yeah, thank you for answer. If provide my clearly. Actually, a small question added.
Yeah.
When you have an agreement with the data owner to share the primary data for statistic purpose.
Can you more louder, please? Because I cannot clearly. Yes, hear clearly.
I think that you have an agreement with the data owner to share the primary data. So when you get the data and you process it, do you share the processed data with the feedback to the data owner or data website?
Okay, the process data. Of course, there are some that are shared. There are some is not shared. We keep that. We keep the process data in our server. For example, for MNO, usually we share the data. So it depends. It depends on the scheme, the schema of the collaborations.
Okay, thank you.
Yeah. Okay, all right. So we still have 50 minutes, I guess. Otherwise, we continue to the next session or break. Is there any other questions, or it's not clear, maybe? Is there? Okay.
Sorry.
Yeah.
I'm Fatur from Asian Stats.
Oh yeah, Fatur.
Yeah, Pak Setia and or Ibu Dhiar. Looking at the objective, I think it's a really good objective. That sorry, the sound of my neighbor. A quick question that do you think any statistic or any indicators that can be replaced by this big data? For example, I just imagine that the price statistic is really possible to be changed by this big data methodology rather than the conventional one that the staff goes to the market and asking something. Using this, I think you can get it easily, and a small error on on data entry, for example. Again, my question is there any statistic that in a short time can be replaced by this big data methodology? Thank you.
No, it's Dhiar time. After that, I can add. Yeah.
Okay, thank you, Pak Fatur. In my opinion, we could use big data, but not in the short time. In the future, we could use big data to replace some of official statistics indicators, I think. But with better methodology, better collection method, and better analysis. And we are currently working on that. I mean, like, we are trying how to get a better algorithm to get the data, and we try to get better analysis to the data, and how to measure the error, and also how many percent the indicators that we have from big data could be trusted for users. But I think for the short time, maybe Pak Setia can correct if I am wrong. For the short time, we are still learning about it. So maybe in the future we could it's not impossible to replace official statistics from with big data. Yes, I think the price statistics is a good example of the indicators. Maybe Pak Setia, Mr. Setia want to add something?
Okay, thank you. Yes, I get as mentioned by Dhiar that official statistic right now still on complementer of the official statistics. But as mentioned, Pak Fatur said that it can be replaced, especially for price statistics. But the price statistics, there are some challenges. Maybe the participant can read our paper. But for price statistics, not only from marketplace data, it should be from scanner data. But that is the challenge will be for area that still don't have access to digital information. And then, for example, Indonesia, there are some areas the digital is not that good. They don't go to supermarket, for example. They don't use digital market. They don't use online shopping, for example. That's still we have to do field survey. That's why the plan is to combine the information of digital data, information of price, and also the survey. But another challenge is that for digital, usually we need to have the data of the price for region, right? Cities, for example. So this is the price of this X, for example, some commodities in this city. But in online digital online data, we cannot get which city that are this price, right? Because everybody can buy from one website and then send it directly to their home with freely. So the price is quite, that's why we plan the research to have digital price index. That's the plan. So we try to combine this conventional price index and also digital price index, especially there with some areas that have connection digital. For other, your question, Pak Fatur, which statistic then can be replaced soon, right? So mobility, statistic mobility, for example, people mobility, that's one we can get very fast. Right now, BPS already used that mobile phone data for tourism statistics as informations as replacing of the. Of course, we still have a data from administrative data. We combine that with the mobile phone, and other data related to mobility and also for infrastructures using Google Map, that also can be replaced soon once we get the information of these two very fast and very good the quality. So of infrastructures of areas, infrastructures of region can be accessed or can be measured by Google Map or Google Earth approach. I think that's from our perspective, Pak Fatur. I don't know whether the same perspective from Malaysia or from Singapore or from other countries. Maybe they can share also their views on that.
Thank you, Pak.
Yeah, Pak Fatur. Okay, Pak Eka and Pak Anang, I think for us is no question. Or maybe shall we hear from a perspective from other countries within this the rest of the time? I give it back the time and floor to Pak Eka and Pak ASEAN Stat. Please.
Thank you, Pak Setia, and also Ms. Dhiar for the presentation. I give a chance again to the other participant if you want to share the question or any experience related with big data before we take a break for 10 minutes. None? Okay. I think we can take a break for 10 minutes. Thank you, Pak Setia.
Thank you. So after that, Pak Ade will take over. So thank you.
Okay, the next session will Pak Ade. Okay. Okay, welcome again, all participants. We are going to continue to the next subject, which is the big data statistical business process for official statistical. For this agenda, it will be led by Ade Koswara. Mr. Ade Koswara, the floor is yours.
Okay, thank you, Pak Eka, right?
Yes.
Okay. First, sorry, I have a problem with my webcam. It's not work, so I cannot turn on my video.
No problem.
Okay, now we will continue the discussion on the topic of big data statistical business process for official statistics. First, if you have any question, maybe you can chat in the chat room. After the presentation, we will try to answer the question. It's a great honor for us to attend this workshop, Big Data Capacity Building for Asian Statistics. We are very glad to see you all today. Thank you to ASEAN Stats for inviting us to join this program. First, let me introduce myself and partner again, who will present for the session. Myself, Ade Koswara, you can call me Ade. For this workshop, the session, I accompanied by my partner, Ibu Isnaeni Novi, you can call her Novi, Ibu Dwi Puspati, Ibu Puspita Sari, Ibu Ita, and Pak Muhammad Hanif. We are representative from BPS IT division, and in big data, we are responsible as data engineer to support Pak Setia team. For this session, we would like to share some of our experience from what we have been done in big data statistical business process in BPS. Before EA, we will discuss about best practice what we can implement in conducting big data utilization, especially in National Statistic Office. One of them is EA. Each of best practice has advantage and can be related each other, such as EA between Gsbpm and GSIM. EA is enterprise architecture, Gsbpm is generic statistical business process model, and GSIM is generic statistical information model. We will present a brief introduction to each of the frameworks, relation between frameworks, and how it can be implemented in big data utilization. First framework we explain is enterprise architecture, EA. We use TOGAF as a framework reference. As shown in this slide, there are 5 layers of EA, enterprise architecture, namely business architecture, data architecture, application architecture, technology architecture, and security architecture. Business architecture layer. This layer includes process flow that will be conducted to achieve the goals and objective of organization. And data architecture explain what data flows at each phase of the business process. Furthermore, application architecture, this layer maps the application use at each phase of the business process and the data that flows in each application use. And technology architecture layer that needed to support the application and data for running proper and efficiently. And the last is cross-cutting layer, security architecture layer to ensure the security for all layers. So with EA, we can also map the current condition with the to-be condition that we expect. The result of this mapping are gaps that we have to fill for moving to the future state from the current state. So from the description of all EA layers and their relationship in brief explanation between layers, we can see the advantages of implementing EA, including helps organization to implement software technology in organized way, bridges gaps between IT and business side, and third, build strategy to move from current state to future state. BPS has implemented this EA to describe the relationship between business processes and IT, such as application, data, technology, and security. Besides that, EA is also useful for measuring the impact of strategic decision that will be taken, such as the impact that will be occurred if you make changes to a current business process. Besides of that, EA organization can do preparation for transition and change management to go to the future state. Next, Bu Ita. The SCAN best practices is generic statistical business process model or Gsbpm. In this slide, we can see the latest version of Gsbpm is 5.1. As we know, Gsbpm describes and defines the set of business processes needed to produce official statistics. It provides a standard framework and harmonized terminology to help statistical organizations to modernize their statistical production processes, as well as to share method and component to another survey. Gsbpm can also use for integrating data and metadata standards or as a template for process documentation, for harmonizing statistical computing infrastructure, and to provide a framework for process quality assessment and improvement. So based on that explanation before, we can draw understanding the Gsbpm as three parts. First, Gsbpm is a collection of related and structured activities and tasks to convert input data into statistical information. We should know Gsbpm should be applied and interpreted flexibly. It's not a rigid framework in which all steps must be followed in a strict order. Instead, it identifies the possible steps in the statistical business process and the interdependencies between them. No, not yet, Bu Ita. Okay. The Gsbpm can be viewed as a checklist to make sure that all necessary steps have been considered, and Gsbpm is a collection of activity components that can be reused for the next survey activity. Next, for this one is Gsbpm earlier, version 5.0. BPS adapt and adopt this version to create our own standard business process. We name it Sbfa, Statistical Business Process Framework Architecture. For your information, actually, Pak Anang is one of the founder of this Sbfa. Good morning, Pak Anang. From a diagram showing the 8 phases of statistical business process. We can see at blue box, it's named level 1, and the sub-processes within each phase at level 2. Furthermore, Gsbpm recognize several overarching processes with a strong statistical component that apply throughout the 8 phases. We can see at the top of the diagram, green one, overarching processes. These overarching processes included quality management. This process includes quality assessment and control mechanism. It recognizes the importance of evaluation and feedback throughout the statistical business process. And second, metadata management. Metadata are created or reused and processes within each phase. Therefore, a strong requirement for a metadata management system to ensure the appropriate metadata retain their link with data throughout the Gsbpm. Third, data management. This includes process independent considerations such as general data security, custodian and ownership, data quality, archiving rules, preservation, retention, and disposal. Fourth, process data management. This includes activities of registering, systematizing, and using data about the implementation of the statistical business process. Process data can aid in detecting and understanding patterns in the data collected, as well as in evaluating the execution of statistical business process. And the last, fifth, knowledge management. This ensures that statistical business processes are repeatable, mainly through the maintenance of process documentation. Okay, for the detailed explanation of process in each level can be found in Gsbpm documentation in UNES Wiki. And then for detailed implementation of EA, Gsbpm, GSIM in big data utilization in BPS will be explained by Ibu Novi. Ibu Novi, please continue the presentation. Thank you.
Thank you, Ade, for the presentation. Hello everyone, I'm Novi and I will continue the explanation about Gsbpm, GSIM, and EA and how it can be implemented in National Statistical Office. And the case is in BPS, Statistic Indonesia. So as explained before by Pak Ade, that Gsbpm is flexible reference model that it can implement by organization based on their requirement or fit where it fit with the organization context. So it is intended that Gsbpm may be used by organization to a different degrees. An organization may choose to either implement the Gsbpm directly or use it as the basis for developing customized version of the model. Maybe some organization choose to implement the Gsbpm directly or just as a reference model to help them to communicating internally or to clarify discussion with external. So when organization have developed organization the specific adaptation of Gsbpm, maybe it will more special based on their organization. So the evidence show that the specialization of the implementation Gsbpm in some organization it's sufficiently not generic and it is not included in Gsbpm itself. So when we implement the Gsbpm, maybe there are some requirement to add one or more detail level of Gsbpm. As we know that Gsbpm has two levels, and in BPS, the adaptation of Gsbpm, namely Statistical Business Process Framework and Architecture, or Sbfa, it has three level, and it is detailed because it can help to for technical implementation in BPS, because when the phase is so general, maybe it not depicts what the detailed process that need to conduct the statistical activity. So we can add one or more level to the Gsbpm. And from one process to another process, we can add a sign of process that it shows the that input from the previous phase is already clarified or approved, and it can be used to the next phase. So the framework is so flexible and not rigid, and we can do a rollback from one phase. For example, we already in build phase, but there are some lack of requirement, so we can get to specify the phase again. In Sbfa is developed by one of participant in here. Pak Anang is the one of team member in developing Sbfa. So in Sbfa, it aims to structure BPS processes and ICT architecture, similar with Gsbpm. In Sbfa, there are in the first level, there are 8 main phases, from specify need to evaluate, and there are overarching components. One of is data and metadata management. There are quality management standard, data and metadata management. So in data and metadata management aims to provide input from one phase to another phase in Sbfa. So it allows to reuse the metadata that is already create in one statistical activity. So if we are as a national statistical office want to make or want to conduct a statistical activity in current year, we can learn from statistical activity that already designed in previous year. So if there are some component that can be reused, is recommended to reuse. So it will have depicts the relation between the statistical activity. So it can efficiency from resources and related with metadata that will use in one of statistical activity. So that is a brief introduction of Sbfa. And the next is introduction about product classes in Sbfa. So in here we can see there are 6 product classes in Sbfa. There are business, household, administrative data, national account, price, statistical analysis for derived data. Based on document, Sbfa document version 4.5, there are different between the product classes. We can see there are a flow. We can see the difference between product classes in the past collect, process, analysis, and disseminate phase. And from data sources that are used from product classes, we can see the difference. For example, for business product class, it uses a large business, small and medium business that is already maintained in Statistical Business Register or SPR. Meanwhile, household product class, it uses not only household frame, but census block master frame too, to activity of sample selection. And for administrative data, it has a important activity that we must consider, that is design of a collection method, because in administrative data we are already know that it is data that already produced by the other public sector or private sector, that we must define how to get the data from its source. It can be manually or by machine-to-machine mechanism. So for machine-to-machine mechanism, actually we must have a cooperate or partnership with a data provider, so we can get the data easily. And for national accounts product class, it uses data from the other product class, for example, from business, household, and administrative data. So if a subject matter area in our division, in our BPS already conducted a survey or census. So the data from the survey or census will be used to produce a national account. So besides the data from survey and administrative data, national account utilize the phenomenon from qualitative information. For example, big data result from Mr. Setia division, the result will be used for complement the national account. For example, the inflation. So it can be support what value that will be released for the public. So in release, actually, usually the phenomena that provide by Mr. Setia division, it will use for supporting the release of national account. So there are the second from the last is price, and the last is statistical analysis for derived data. Actually, the statistical analysis for derived data is referred to administrative data, or refer to a national account process, because the data sources is similar, but maybe the indicator that is produced is different from national account product class. So the next, this is a introduction of product classes in Sbfa. We move to the third best practice that will introduced by us is generic statistical information model, or GSIM. So why we use GSIM? Because maybe we already have information or a data model in our organization, but to conduct statistical activity, there are metadata that must be used to ensure that all of the information that we need for statistical activity is documented. So this is the role of GSIM. In here, we can see that GSIM has relation with the other standard like DDI and SDMX. And for the implementation is same with Gsbpm, is not a rigid framework. So you can flexible to implementation based on the organization needs. In BPS itself, the use of GSIM is already implemented in we need more than 1 year to implement the GSIM, and the version of information model that BPS BPS have now, it's will always revise based on the development of requirement. So what we define in information model based on GSIM, it will start in metadata management system, and in each of phase of Gsbpm, we already know before, from specify need to evaluate, it has so each of phase will has a metadata that will be input for the next phase. So if we now just collect metadata in the end of activity, statistical activity, now we want to more use metadata as metadata driven. So each phase must be produce the metadata, and it must be directly stored in metadata management system, so it can be used to another phase. So it and when we start to conduct statistical activity, maybe we want to design what our activity needs, and that is we can use metadata as a reference, metadata that already stored in metadata management system as reference. If there are components or maybe methodology design or variable design or indicator design that can be reused for our current statistical activity. So it more efficient. We don't have to add variable again if it's already stored in metadata management system, and it has a concept and definition same with our requirement. So that is efficiency aspect in the use of metadata. So in the right side is example of how the objects. So in GSIM there are five main objects, five main objects there, and this is one of the objects in GSIM. There is this is a business case object, and the group. I'm sorry, I revise. So there are five groups in GSIM, and one of the group is business group, and business case is one of the objects of business group. And this is a relation with the other objects, such as when we start to conduct a statistical activity in the design phase or in specify need phase, we will produce a business case. Business case is will initiate the statistical program design for existing statistical program or for new statistical program, and when we update the statistical program design, we must based on a change definition, so it will it will explain what change in the design of current statistical program and the previous statistical program. So this is the brief introduction, and the next is how Gsbpm and GSIM is related. This is from the picture we can see that GSIM will be provide the input for Gsbpm. Some the example of the input, it can be dataset, variable, or parameter input. And when the input is used in Gsbpm sub-process, it may produce the output as the transformation of the input that already used in the process. So when we use the Gsbpm and the GSIM together, so it can facilitate the building of efficient metadata-driven system to help harmonize statistical computing infrastructure. So from the concept, it has opportunity to repair what we have done currently. So we can use metadata as a powerful resource to automatization of our business process. The next is, I already talked about the concept, Gsbpm, GSIM, and what is an example of the use of GSIM in our office. So this is a diagram illustrate how the information of metadata is flow from one system to another system. There are corporate in statistical infrastructure too. In the box, there are frame and register system, integrated collection system, integrated dissemination system, and there are a system that overarching in the whole business process base. There are data management system and metadata management system. So in the first frame and register system, it is a system that is used in specify and design phase. It will produce a business case that already mentioned. Business case consists of what is a statistical program that we will conduct, and we will be conducted, and what is variable indicator that will be used for the statistical activity that we design in frame and register system. And the output from frame register system will be used in integrated collection system, because in frame and register system we already defined about the variable, the indicator, and the variable of course will be related with the question in the questionnaire that will be used in the statistical activity. So in the integrated collection system will be designed the statistical questionnaire, will be designed a questionnaire that will be implemented in collection phase. So data from integrated collection system, because we already have a questionnaire and we already do enumeration, so the data will be stored in data management system. And in data management system, there are three kinds of repository. There are data lake, output data warehouse, and dissemination data warehouse. What is the difference? What we'll have, what we already have from integrated collection system will be stored in data lake, and it will be processed in data lake, because already technology that we have implement is Hadoop. So it can be used to process for data with a large size. So we use a data lake, and for disseminate data internally or externally, we use to storage for separation of that output data warehouse for internal access, meanwhile dissemination data warehouse for external access. So metadata that is flows from one system and other to another system, it depicts the reuse of metadata. And for the last, when we disseminate from integrated dissemination system, so integrated dissemination system will publish the data that will have collect and process and analysis. So in this, it will use metadata management system to query the data. So the query is not directly to data management system, but based on metadata management system, because what we store in data management system is already registered, the metadata. It's metadata already registered in metadata management system. So integrated dissemination system can know what indicator that is already available in DMS, and what is the disaggregation, and all of the query from EDS to DMS will be from metadata management system, and the query that is already achieved or accept from metadata management system will be sent to data management system, and data management system will give the data based on the parameter that is from EDS. Like that, this is the use of metadata. So what we do, what the system do, whether it's technical metadata, business metadata, and operational metadata is can be stored in metadata management system, and we must relate between data and metadata to get high benefit from the implementation. So this is the next is mapping from statistical infrastructure and business process that already mentioned before. Maybe I will skip for this because we already did talk previous. And so why we explain about Gsbpm, GSIM, enterprise architecture. What is the aim? So in this slide, we want to talk about that from Mr. Setia explanation. There are some characteristics of big data. In this, we just three characteristics. There are velocity, volume, and variety. And from based on UNES, there are big data classification. So if we remember what Mr. Setash said, that there are ex-house data, sensing data, and digital content. So based on UNES, there are social network. So social network is what data there is, what same with digital content, yes, right. And the second is traditional business system is same with ex-house data, and the last is Internet of Things. It's same with sensing data. So there are many data. No, in the digital era, there are so many data. It is not just structured, but also unstructured data. So big data is a new source that is used to support official statistics, but from what we expect is big data can substitute the what we already done, like conventional survey or census. And so in the next, we just have to collect data by machine-to-machine mechanism. So because it has a characteristic like volume, variety, and velocity, so we must consider that the huge amount of potential data to be explored. So might prefer to collect as much data as possible without carefully consider the actual output they need. So more data does not mean more insight if we don't know how to process and analyze it. So, however, it will be wise to perform a preliminary literature study and assessment to obtain clear objective for any data analysis based on user need and not merely driven by data availability. So, maybe in external, there are so many data, but we must consider what actually we want to produce from the data. So in this picture, we can see there are business process and the detail of a specific activity in each phase is that here. And the next, in the next slide, we will talk about combine the framework that already mentioned by Mr. Ade. There are enterprise architecture and the Gsbpm and GSIM itself. So this is the framework that we try to build to explain how big data utilization in a systematic way, because in some reference, for example, from UN Stat, they state that data source, big data as a data source is not much different from the other data source. So we must have to ensure the quality and how is the coverage of the data, because we aim to make a big data for official statistic, right? So we must carefully to conduct each phase of in big data utilization. So for example, in specifying it, we must consider about what is our analytical objective, and we must check the data availability, because when the data is free, but we don't know about the continuity of the data. So maybe we can get the data for 2 months, but the next month we can get the data again, because the data provider is not provide the data, and we can make the data provider to meet our requirement, because we just crawling the data, but we don't have a communication with data provider. So in this phase, in specifying it, data partnership is very important to conduct big data utilization. So the other phase must be carefully conduct is when we collect the data, because in specifying it, we have assumption that we already know what data will be collected, and we must know how to accessing the data. Of course, if we have the MOU with the data provider, it will be more easily for us to get the data. Meanwhile, if we just crawling freely the data from the website, we have a risk about the continuity of the data. So in based on EA, previously mentioned by Mr. Ade, there are five main layers. They are business, data, application, and technology. In this framework, we try to place the layer in this picture. For business process, we adopt the Sbfa. For the data, for the flow of data and metadata, we use the GSIM. So in this, just a brief picture of what is input or output from each phase, but the detail of data layer, it will be more than this. There are several attributes that must be filled to ensure that the metadata is complete. And the application is support the data flow, and the feature that it is needed for business process running well. And the technology itself, it's related with the hardware, and the hardware that will support the application. So when we have application for support the business process, we must consider about what is the hardware requirement. So what application that we already have will be running well. And the last is role, because in this sharing session, we will learn about what is the role of data engineer, what is the role of data scientist. Actually, there are many roles that we can make, not limit to data scientist and data engineer, but maybe we can add the role of data partnership, because it will help us to ensure the communication with the data provider. And we maybe for database, we must add a database administrator, so it can ensure the security of our storage, and database administrator will monitor the performance of database, because we talk about data, so database is one of main component um, in this flow. So, and there are other components that overarching. There are standard, method, quality, security, and governance. Because actually, in previous diagram we talk about data lake. We have we already collect much data from internal and external. We must ensure the metadata. So we must state that in the governance document, so it can be referred for each of role in our big data ecosystem, like that. So for explanation of statistical business process for big data, maybe till here that you can read more about how the case of implementation the enterprise architecture for big data in our paper. Maybe it's already displayed in Dhiar slide, so you can read in there for detailed explanation. Maybe from me, it's just that. Back to Pak Ade.
Okay, thank you, Bu Novi. What's the rundown, Pak Eka? Is it we start to discussion or continue with data governance?
Yeah. Yes, I will continue with Bu Ita.
Okay, Bu Ita, please.
For the opportunity, Bu Novi and Pak Ade. Okay, so continuing from the explanation from Bu Novi and Pak Ade, I will try to continue and explain about data governance specifically for big data and also for data in general. Okay, so previously, Bu Novi and Pak Ade have already explained about the international best practice that's out there and the one that we use in Pps Statistics Indonesia, specifically regarding the overall architecture and also from the business process side. And now we're going to move on, especially in the data governance aspect. Next, please. Yeah. Okay, so before I explain in detail about what is data governance and what is data management, I want all of us to be on the same page and to realize the importance and urgency of data governance. So what is data governance and why organizations need to govern data? Here are several points regarding as an answer for the question. And just for an additional note, these points maybe not specifically applied for big data, but also for overall data. So the first point is to avoid inconsistent data silos in different departments and business units. So as we may know, each unit in National Statistics Office may collect their own data, and later on in this age may collect their own big data. So we need to ensure that there are no inconsistency between those data, and the data is not silo anymore. And then we need to agree on common data definitions for a shared understanding of data, because then again, each unit and other units can have like different concept of the data. So we need to find a way to find a common data definition for that. And we also need to improve data quality through efforts to identify and fix error in datasets. As has been explained by Pak Setia before, we know that in big data, there are many errors, just like in traditional data, especially regarding like noises and then missing value and something like that. We need to find a way and solution to improve the data quality. And next is we need to increase analytics accuracy and give decision makers reliable information. This point is related to the one that Dhiar has explained, that later on we hope that big data can be used for small area estimation, which can increase analytics accuracy until the smallest level of region. And then we also need data governance to implement and enforce policies that help prevent data errors and misuse. This one is regarding, it's related to the last point, that is to help ensure compliance with data privacy laws and other regulations. So as we know, as with the emerging of big data, with the amount of data that keeps on increasing, the other issue that arises regarding data is ethical use of data. Like one of the example that also been mentioned is about data privacy. Whether or not, I mean, we can collect data freely, but maybe some for big data, but maybe some of those data contain like confidential or privacy information. So we need to manage that in order to protect the privacy of the owner of the data before we deliver the data to the consumers. Yeah, so that's some of the reasons why data governance is very important. And then moving on from, after we have understand the important and hopefully we can realize the urgency of that, we're going to move on to the explanation of the basic concept of data management principle. So data governance is basically a part of data management data management is like the bigger part, and data governance is a part of that. So data governance principle is basically similar to data management principles. And what are those? The first one is that data is valuable. So maybe lately we have heard that data is a more valuable asset compared to oil or whatever, like we know the slogan about data is the new oil. And that's because data is a very valuable asset with unique properties. And maybe for us, for like National Statistic Office, we don't like monetize the data directly, but we also need to realize that in the future, in the long term, that data can bring a great benefit to the government in a whole. And then the next principle is that data management requirements are business requirements. So this is regarding the data-driven or needs-driven. So yeah, sometimes the both of them are needs to be combined, like to build your own data management requirements, you will first need to understand what is your business and your organization's requirement. And then for that, we need to also note several points, like managing data means managing the quality of the data. So you can just like manage the data without considering the quality of the data. And then just like it has been explained before by Bu Novi, for data management to work properly, we need to ensure the appropriate use of metadata. And we also, in the specified needs phase, we also need to make a proper and like clear planning on how to manage the data also. And then finally, data management requirements must drive information technology decisions. So if you remember from the previous explanation, there are like business process layer, and then there's the data layers from business process, business requirement, we like derive the data management requirement. And then from that, we derive the information technology requirements. So from the data, then we can analyze or we can identify what kind of technology that we need in order to manage that. And then the third principle is that data management is also life cycle management. So in Gsbpm and also Sbfa, we have seen that the data phase is not only like a singular phase, but it consists of several phases that's like subscale from each other. And then different types of data have different life cycle characteristics. So this is talking about like, you know, in Sbfa, there are like 8 phases, starting from specify needs to evaluate. And then there are several product classes like national accounts, and then derived data, price statistic that has been explained. And some of the data may have like different life cycle from each other. For example, because national accounts is using data from other sources like census and survey, so they don't necessarily have like the their own collect phase. Instead of they collect the data collection used from other survey. And then throughout this life cycle management, when we manage the data, we also need to manage the risks that associated with the data. So for example, in the collect phase, what are the risks there? Like what if there's like missing data? What if there's non-response? What if the data is unavailable? We need to take that points into consideration and try to mitigate and identify the possible solutions for that. And then the last principle is that data management depends on diverse skills. So data management is a cross-functional principle. It's not like just because maybe from the title itself, data management, it sounds like a high level aspect kind of thing, but actually it's not. It not only requires like managerial aspect and knowledge, but it also requires technical skills. So yeah, it needs the second point, data management requires an enterprise perspective. This is because we need to understand the business requirement and that alignment with organization needs in a whole. So we need managerial aspect for that, managerial knowledge for that. But we also need to account for a range of perspectives. That is the last point. And this range of perspectives is talking about like the technical skills, like starting from the technical issue regarding the data and then technical issue regarding the technology to manage the data. Okay, please next. Yeah. Now that we have understand the data management principle, we're going to talk more specifically about data governance. So this is like, let's call it this data governance wheel. And I take this from DAMA, data management book, data management body of knowledge. Yeah, I forgot to mention this before. So basically for data governance and data management, the international best practice that's out there is data management body of knowledge. And it was published by Unistats Wiki, similar to the other best practice. And yeah, for this, we refer to that mostly. You can find it in the internet. Currently, the latest version is version 2. Yes, and then now we back to talk about the data governance. This is the data governance wheel that we are going to talk about. As you can see, basically there are like 3 main components of that. That is the data governance itself. And yeah, you can see it as the outer cycle. And then the life cycle management, the triangular shape. And then the foundational activities, the one below the life cycle management. So what is each of this actually? Well, I'm going to try to explain them one by one. And just to remind you, if there's anything that you find unclear or you find confusing, you can always ask and type your question in the chat box, or we can discuss it later. Okay, so basically, we're going to talk first about the foundational activities. So foundational activities like data protection, privacy, security risks management, metadata management, and data quality management, it's an activities that span throughout the data lifecycle. So just like previously in Sbfa or Gsbpm, there are like data quality and metadata and data management as overarching components. This one is also an overarching activities that needs to be defined first. So yeah, identifying them will help us to enable better design decisions and make data easier to use. And if these activities are executed well, data is less expensive to maintain, and data consumers will have more confidence in it, and the opportunities for us to manage and utilize our data to its fullest can expand. So for metadata management, well, maybe I'm just going to talk about several sample of them, not all of them. For example, for metadata management, as has been explained before, with the use of metadata management, we can like ensure like that each process are conducted correctly. And so the information of the metadata information can help us like determine whether or not the process has been done correctly. And it can also like act as a documentation for the process that we have done. And then later on, if we want to conduct another activities, let's say another surveys or another big data activities, we can refer to that information, to that metadata, and we can evaluate what went great, what went wrong, what can be improved, and something like that. And by having that, our next activities, our next big data collection maybe will be better than the previous one. And in turn, this will like improve our overall data protection. Okay, so that's the importance of foundational activities. And then the life cycle management. So the life cycle management is containing a set of domains that need to be maintained throughout the life cycle phase. So for the data governance or data management, the life cycle is basically divided into three parts. That is plan and design, and then there is use and enhance, and at last there is enable and maintain. So each of the phases containing the term is like knowledge area or data domain that's need to be maintained in each phase. So for example, in the plan and design, the knowledge area or the data domain is that needs to be maintained is architecture, modeling, and design. So in data governance and data management, first of all, we need to plan and design the architecture of our data. And for this one in Pps Statistics Indonesia, maybe we have seen it in the previous explanation in our framework for big data. That's one of the example of the architecture that we have designed. And then we can move on to like breaking down that high level architecture into like a more technical modeling, because you know there's like several data modeling concept, from like conceptual model, logical model, and then finally physical model. Yeah, and then we can design how to use that architecture and those data model. And for use and enhance, it explain how we use what do you call it? The architecture, the design that you have created in the previous phase, and use and enhance them to support the organization's needs. So the kind of knowledge or domain that we can use or enhance are like data science, data visualization, data monetization. Well, because this is a general framework and not only but NSO. Maybe for NSO, we can like define it differently, the monetization part. And then there is like predictive analytics regarding to the data science, and then master data usage. Master data is like, what do you call it? The reference data, it's similar to that. And then business intelligence, and finally document and content management. So yeah, after we have plan and design our architecture, and we can, after we define the metadata management for that, we define the security risk management and data quality management, we can apply all of that to use and enhance this data domain. And finally, we can also enable and maintain another part of data domain. For example, like big data storage, data warehousing, master data management, and then data storage and operations, reference data management, and also data integration and interoperability. So this one, like the domain in enable and maintain, it's more like the more advanced part of the data domain in the use and enhance. So the use and enhance is like the basic domain that we usually use in our operational activities, and enable and maintain is more like the advanced activities like big data, something like, and data integration and interoperability. Yeah, something like that. And then finally, we will talk about the outer cycle, that is the data governance, and it contains a set of required components for effective data governance. So similar to foundational activities, this one is like an overarching activities, but the difference is for foundational activities, mostly you need to define them at first, but for data governance, you can define them along with implementation of the data governance itself. So some of the components, it's like the policy. Okay, so one of the example of the policy is like data need to be related and to be linked with its metadata. That's one of the policy that's needed in order to support the use and enhance of this data domain or the enable and maintain of this data domain. And then there's also stewardship and ownership. This is regarding like the division of roles and responsibility in data governance. So we need to know who is in charge of what, who is in charge of what. So we can ensure that each of the roles have their own set of responsibilities. And so in case something goes wrong, we can ask and we can like, yeah, we can ask the right person in order to solve that problem. And then there's also culture change or change management. It is to ensure that throughout the implementation of this lifecycle management, in case there's like resistance to change or in case there is need to transform a business process from like the current state into the future state, we need to ensure that all of the stakeholders and of the employees will be able to support that. And we need change management for that. And then for the strategy, it's also similar. It's basically the strategy to implement all of that. And then there's also like principle and ethics regarding how to use that data, how to manage that. And then there's also data evaluation. This one is similar to data monetization, but this one is more like the general term. So in order for us to perform well and smooth data governance, we need to ensure that the cost in collecting the data is worth it. Like we need to ensure the cost for collecting the data is equal and yeah, equal to the benefit of the benefit that we gain from obtaining the data. And then there's also data maturity assessment and data classification. Next, please. Okay, so from the wheel of data management body of knowledge previously, now we are going to talk about how to design our own data governance that's suitable or appropriate according to our organization needs. So in data management body of knowledge, there is like this diagram, context diagram. This is basically a guideline to help us design our own data governance. It mainly consists of definition, goals, and then the business drivers and the technical drivers. So this one is an example of how to design a data governance. So first you need to define the goal. Why do you want to implement a data governance? Like for example, the goals is we want to enable an organization to manage data as an asset. And then we want to define with, maybe you can download the book later to get a clearer picture of this. Yeah, so basically first we need to define our goals. And then we can, after we define our goals, we need to define the business drivers that we need and the technical drivers that we need in order to realize and achieve those goals. So to help our organizations to manage the data as an asset, we need several inputs. You can define inputs as something that you need as basic information. Yeah, that will help you to plan out the next activities. So for this example, the inputs is if you want to like create your own data governance, the inputs that you need are business strategies and goals, and then IT strategies and goals, and then data management and data strategies, organizational policies and standard, and also business culture assessment, data maturity assessment, IT practices, and regulatory requirements. So mostly this, for this case, mostly these inputs came in the form of like document or like legal product, something like that for regulatory. And yeah, basically we need them in order to understand what is the important or the main needs of our organizations. Like our goals is we want our organization to manage data as an asset. But before we can achieve that goals, we need to first realize what is our organization's needs and why it needs to manage the data as an asset. Then now we can use that inputs to define that. And then after we gather the information that we required from the inputs document, we can plan the activities that we need to do. For example, the first activity in designing a data governance is define data governance for the organizations, including develop data governance strategy, perform readiness assessment, and then perform discovery and business alignment, and finally develop organizational touch points. And then after we define the data governance for the organizations, we can define the data governance strategy. We can like define which framework we want to adopt, which one we want to use, and how we're going to modify that to suit our needs. And basically that's the main point of the second activities. But in details, you can see there are like, the first point is define and data governance operating framework, develop goals, principles, and policies, and underwrite data management projects, engage in change and issue management, as we have talked about before, and finally assess regulatory compliance requirement. And then after you define the data governance and data governance strategy, you can finally implement that data governance that you have designed. This is the points that you can do when implementing data governance. And then finally, you can embed data governance. So embed data governance is basically like, maybe in the future, in the long term, you can like turn this data governance into some legal products, like regulatory requirement to be used for other aspects. And then after we have gathered the inputs, we've done the required activities, we can finally, produce a deliverables. And our deliverables can be data governance strategy and data strategy, and yeah, some of that. You can read it. And that's the business drivers that we need to design a data governance. Now moving on to the technical drivers. For inputs, so technical drivers is basically something that help you to find the business drivers, to support the business drivers. Like for the example, for the inputs, this document, we can obtain those documents from the suppliers. The suppliers can be like business executive, because usually they know the vision of the organizations, they know like the high level needs of the organization, or maybe the data stewards or data owners, subject matter expert, and some other roles that's there. And then during the activities, during performing the activities, we need to include several participants, for example, like steering committee, chief information officer, and then chief data officer or chief data steward, executive data stewards, and so on. It depends on your organizations, you can modify that. And then finally, the deliverables, we need to ensure that our deliverables can answer and like, basically answer the needs for the consumers. And the consumers for data governance product is data governance bodies, project managers, compliance team, and so on. So the product of this activity is data governance, and those data governance finally can be used as a guideline for other teams or other project manager officer when they conduct their own activity regarding data collections. I'm sorry, I need to revise myself. Supplier, participants, and consumer is still part of business drivers. And then the technical drivers, like the technical parts, this one is the technical part that we need to support those. For the example, is like for tools. Tools to implement the activities, we can use like workflow tools or document management tools. And then we can also use like a website or something in order to help us to find the necessary information or to put the necessary deliverable for it to be accessible. And then we can also use some metrics. This one is useful to ensure that our deliverable is compliance to regulatory and internal data policies. So for example, our deliverable is data governance. We need metrics, and the metric usually consists of questions like, is data governance in alignment with organization needs? Is data governance able to help the organizations find a solution for its challenges, something like that. We need to answer these metrics to ensure the deliverables that we produce is in a high quality. Yeah, so basically that's like the overall explanation of this part. And then the next slide, please. Yeah, so after we talk about the international best practice of data governance, we talk about how to design our own data governance from the guideline that has been provided. I'm going to share a bit about data governance in PPS, but just for you to know, we're also still learning to improving that. So this is not a final document. This is like a living document that will be continuously improved and maintained. So in last year, in 2020, we have designed a data governance draft for our data management, and we designed that based on our organization needs and our IT strategy and goals. And later on, hopefully, if it has been reviewed by several stakeholders, if we have deemed it's qualified enough, then maybe we can formalize it into a legal product. And basically our data governance book, let's call it book, consists of three main parts. That's development phase, operational phase, and maintenance phase. This is similar to the life cycle before, like plan and design, use and enhance, and then finally enable and maintain. So in development phase, we're going to list out activities that we need to perform in order to like develop data management or maybe a data management system. And then in the operational phase, we list the activities that we need in order to ensure that the operational activities of the organizations can run smoothly. And then for maintenance phase, we're talking about how to maintain what we have developed and what we have performed in our daily operational. We need to maintain that in order for it to be sustainable. And then for each of those parts, there are several main components. That's activities that I have explained. And then there is also standard, policies, procedures, role as responsibilities, or we usually call it like RACI metrics. I will talk about it later. And finally, the quality metrics that I have briefly mentioned earlier. And next. Okay, so this is like a more detailed explanation, a more detailed example of that in order to help us gain a better understanding of this. So for the example, one of the activity during like development phase is data migration, right? So when we first develop our data management system, we need to move our existing data that is in different repositories and whatsoever. We need to migrate it into our single source repository. And then for that, we need data migration activity. And the related policies for data migration activities is, for example, data source policy and data acquisition policy. So the activities will explain like how the data migration process should be done, and then the policies list out the point that we need to follow when we conduct this activity. Like for example, a data source policy might consist of a point that say a data source that can be migrated to single source of repository is blah 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 blah, like something like that. And then data acquisition policy might have a point like the data acquisition method that can be used is like machine to machine, ETL, or something like that. It's the example of policy. And then for standards, the related standards, maybe we can have like data ingestion standards and data source standard. So for data source standard, maybe one of the point is like the data source that's used for migration needs to meet these following criteria. And maybe this criteria can be like, it is accessible, it contains data that's like still in a timely manner and not out of date, something like that. And for data ingestion standard, this can contain several points like the format of the data that can be used for data ingestion or data migration, and data type, something like that. Like usually the standard is more like technical. Sometimes it is a set of criteria that needs to be met. And then for procedures, this is basically like the step by step or a more detailed step in order to conduct that activities. And then this picture is an example of a set of activities that we have. If you can see it, there is the point A is for development, point B is for operational, and C is for maintenance. And then for each of that, we have standards and policies, and we ensure that each of them are linked and related like this. And next. Yeah, and this is about the procedures. This is the example of procedures. So you list like the more detailed activity. And then for each of that, you need to define who is responsible and who is in charge, which role will be performing for that. You define that basically for procedures. And then for roles and responsibility, this is this is similar to the procedures, but this is more like you need to know, like for example, for this one, chief data officer. Chief data officer is also taking part in data ingestion, but his contribution, he's not the one in charge. So basically, RAICI matrix stands for responsible, accountable, consulted, and informed. So chief data officer also takes part in data ingestion, but he's not the one responsible. He's not the one in charge. He's not the one doing the ETL or machine-to-machine acquisition, but he is his role is only to be the one that's going to be informed. So if a data ingestion activity is to be performed, we need to inform the chief data officer. And then, for example, like, so who is the one that's going to be in charge? In this matrix, we can briefly see that the ones that's responsible is data integration specialist. So he or she is the one that's going to do all the ETL and technical stuff. And for that, he needs to ensure to consult with data steward team and then inform the chief data officer and data management executive. Like that's one of the example of roles and responsibilities or matrix RAICI. And lastly, I'm sorry, this one is like a typo. This one below roles and responsibilities, it's supposed to be like metrics quality. So yeah, this is the example of the metrics quality that I have talked about before. So you define the indicator, and then you can assess your own activities, whether or not the activities that you've done has met those indicator. And then we can also like define a threshold, like for example, whether or not the data that's migrated has been migrated successfully, completely, accurately, something like that. And maybe you can like range it in the scale from 1 to 10, and the threshold is 7. So if it passed 7, then it's considered success, something like that. That's the use of quality metrics, basically to ensure that the activities you've done is done correctly according to the standards and procedures. Okay, well, I think that's all for data governance and data management. Maybe, I don't know, if we have time, we can have discussion session, or yeah, back to Pak Ade or Pak Setia. Thank you.
Sorry, here is the call of prayer, Azan. Maybe Bu Novi, could you be a moderator for the discussion session?
Ada. So for all of the participants, we can start to discussion. If you have some question for us, or maybe we can sharing experience about what we already done in our organization, about business process in big data utilization, or how is the challenge that you have already faced when you start to implement the big data utilization. Maybe we can discuss from there. Or if you don't have question, so we have to ask you about what your experience. So is there any question? So maybe if you don't have any question for us, maybe in the list of participants, we can see it's from some countries like Cambodia, Laos, Malaysia. So maybe we want to hear experience from some of national statistical office in here, some of the representative of national statistical office in here when conducting the big data utilization in their country. Maybe from Malaysia, because we already communicate with Malaysia, so we know that they have already collect the data. There are a representative from Malaysia.
Yeah, maybe our colleague from Malaysia want to add something related with the subject have been present by BPS. Maybe Malaysia have different view about the implementation. Very quiet. It mean everybody understand and clear, or it indicate that there are too much subject that have been present, so it is difficult to start which question to be asked. Any question from participant? I think no question. Pastia or other from BPS want to add?
Can I ask a question, Pak Eka?
Yeah, please, Panang.
Yeah, after seeing and listening to the explanation of the frameworks, Gsbpm and GSIM, and also on the enterprise architecture, and also on the data management. Of course, when we come into the implementation, there are always some issues. There are always some issues for us to be able to implement in an ideal way. So what I want to ask is for BPS to share with us your experience in dealing with some issues. For example, when you meet difficulties or limitation that make you not able to implement the framework ideally or comprehensively. So what did you do in dealing with that? Maybe you can share us the experience on selecting the priority, for example, or in any other issues. That's my question, Pak Eka and colleagues from BPS.
Thank you for your question, Pak Anang. Maybe my colleague will add the answer. My answer. So the implementation, whether it's data governance, enterprise architecture, or Gsbpm and GSIM, we already mentioned that we have Sbfa. of course, it has a challenge because most of our division is have comfortable with the current state. And for example, we have a plan to implement metadata management system. That is, and the object of metadata management system is so many. If GSIM is have around 130 object, so we have to squeeze the object and uh, choose what is the main object that we must to implement in BPS. So when we want to ask the other division, like a division that has a role to maintain classification and standard for the data, they have difficulties in uh, fill the content of metadata because the attribute is so many, and to migration from existing system of metadata, because BPS already have the system, it must it will need much effort because not all the attribute can be filled from the information that available currently. So yeah, the effort for buy into our to the other division to contribute to fill the content of metadata management system is we always try communicate with them, and now we start to collaborate how to fill the content. So in standard and classification, there are some challenges too, because standard and classification that is released from BPS is used by the other ministries. So the communication of the standard that is released from BPS to the other ministry is must must apa ya gencar. Must I have to communicate regularly, so they have aware that when they start to conduct statistical activity in their ministry, there are standard and classification that must be followed. So when we want to integrate the data from our BPS from BPS to another data from external, it must be more easily. Maybe the challenge, there is a example of the challenge when we want to implement the one product, it is a metadata management system. Maybe my colleague Ita or Pak Ade want to add the answer.
Okay, thank you, Mbak Novi. Maybe I'm going to add a little bit to that. One of the issues that we also face is regarding the data migration or data ingestion that I've just talked about. So maybe, for example, we have like a certain standard or policies regarding what types of data we can store in data lake and what kind of formats and how long they can be stored there. There's like a standard of data retention standard, but sometimes what we have defined is not suitable for like operational use. So maybe like we have planned for automatic data ingestion, but currently it's not possible because there are like a challenge in the data format during data conversion or during data ingestion. So sometimes we need to adjust. We need to adjust we need to adjust the process, because as to reach that ideal phase, the data governance is mostly consist of the phase that is ideal, like the ideal standard, the ideal policy. But sometimes when we're on the early phase of our implementation, especially regarding this big data and data lake, there are a lot of things that we still need to try to figure out, like how the automatization works, how to ensure data is accurately and completely migrated, and how to effectively process that data. We're still working and trying to find the what do you call it, the good pipeline for that. So yeah, maybe sometimes when we're still in early phase of a project, sometimes we don't always follow the data governance, but we need to ensure that we are working to improve the condition so we can finally reach the ideal condition. So for the example, if the data format is currently maybe like the standard format is like ORC or something, but currently you only have CSV, then maybe we can work with that first. And yeah, basically we need to identify it from all aspects, like whether it's really urgent or not, whether it is really important or not. If it's really urgent, then sometimes yeah, we use whatever is available for for now, and then we'll try to improve it in the future. I think that's what I can add.
Okay, thank you, Mbak Novi and Mbak Dwi Puspita. So in short, it is pretty much possible, yeah, for member states, yeah, because we have 10 member states with variety in terms of capacity, in terms of resources. So it is very possible, yeah, for the framework, including the governance, to be adjusted and to be compromised, yeah, considering the current situation of each member state. Yeah.
Yeah, I believe that it's really possible.
Yeah. Thank you.
Any other question from the participant? Yeah. It seems no more question from the participant. As the time has been reached, I think we can conclude the session for today. And we continue with tomorrow session. Yeah, for tomorrow, I believe the subject is considered more detailed. So please anticipate because let me share. Okay, besok. I mean, this is the subject for tomorrow. Only one subject, so it will be quite long subject. Okay, for tomorrow we will have Mr. Takdir, Gary, and also Muhammad Lukman as our trainer. Okay, we can end our session today and meet again tomorrow. See you, everyone.
Thank you, everybody. Pak Setia, can you stay for 3 to 5 minutes?
I think I can see Setia in the room right now, Panang.
Oh, okay then. So it's okay.